Hey there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-3 Part 1 homework solutions on logarithms.
For number 1, they want us to write this logarithmic form into exponential form. So basically what's happening here is we're keeping the same base of 4 and switching the input and the output. So we're basically saying 4 to the second equals 16. And I mean, this is a true statement, so there's that too. For number 2, we're putting this into exponential form. Using the same base, we've got 4 to the third equals 64. For number 3, they want us to write this in exponential form. So we've got 6 to the negative 2 equals 1 over 36. For this problem, we're being asked to write this expression in exponential form. So the base of 3 is going to remain a base, and we're just going to switch the input and the output here. So we're going to have 3 to the fourth equals 81, which is a true statement. For number 5, we're asking indivisible 10 to the what power equals 0.01, or 100th. So this would end up being the negative 2 power. For number 6, we're supposed to simplify this logarithm. So this negative 4 out here looks a little bit tricky, but a technique you can use on this is let's just figure out log base 3 of 243 and then multiply it by negative 4. So for this log part, I'm asking 3 to the what power equals 243. Well, that would be 3 to the fifth. So this is just negative 4 times 5, which comes out to negative 20. For number 7, we're basically asking 2 to the what power equals 64. And that would be 2 to the sixths. On this problem, we want the log of 0.001. So this is really log base 10, and we're essentially asking 10 to the what power equals, well, I guess we could express this as 1 over 1,000. This is 1,000th after all. So what do I have to raise 10 to get 1 over 1,000? Well, this would be 10 to the negative third power. So then the log of 0.001 is going to be negative 3. For number 9, let's simplify the logarithmic part of this first. So we're basically asking 9 to the what power is 81. That would be 9 to the second power. So rewriting this now, we just have 9 times 2, which is 18. For this problem, we need to take the log base 2 of 32 and then multiply that by 7. We'll deal with the log first. So we're essentially asking 2 to the what power is 32. Well, 2 to the fifth is 32. So this is then going to be 7 times 5, which is 35. For this problem, we're trying to find the log base 3 of 27. So we're essentially asking 3 to the what power is 27, and that would be 3 to the third, so the answer is 3. For this problem, I want the common log of 10 to the 33. This is really log base 10, so I'm asking 10 to the what equals 10 to the 33, and the answer is just going to be 33. So the base and the base there are going to cancel. For this problem, I want log base 7 of 7 to the 11th. So I'm asking 7 to the what power equals 7 to the 11, and that's going to be 11. For this problem, I'm doing log base 20 of 1. So 20 to the what power equals 1, and that's going to be 0. In fact, the log base, pretty much anything of 1 is going to be 0. On this problem, I want the log base 1 of 4, so I'm asking what do I have to raise 1 to in order to get 4, and it turns out there's nothing you can raise 1 to get 4 because you're always just going to get 1 no matter what you plug in. So this has no solution. For 16, I have an invisible base 10, so I'm asking what do I have to raise 10 to in order to get 10 to the 25th. If you have the same base here and down here, they basically cancel each other out, so we get just 25. With 17, notice that we have the same base here and here. The bases are going to cancel. We're just going to get the exponent in this case of 10. For 18, I'm asking what do I have to raise 8 to in order to get 1. And anything to the 0 power is going to give you 1. For 19, I'm asking what do I have to raise 1 to in order to get 2. And this is a fool's errand because no matter what you raise 1 to, you're always going to get 1, so there's no solution to this one. On this one, I'm going to do the log part first and then multiply it by 4. So ln, remember, is really log base e. So I'm asking, what do I have to raise e to in order to get e to the 8th? So you always just get the exponent when you ln and e. So that's just 4 times 8 then, which comes out to 32.